Yo, what's up everyone? Patrick here, welcome back. And in this next example, what we gotta figure out is basically how many asymptotes this function has. 3x squared plus x over 3x cubed minus 6x squared plus 7x. And it's gonna be one of these 5 choices here. Either it's gonna have one vertical asymptote, put it in short form, and one horizontal asymptote, 2 vertical asymptotes and 1 horizontal asymptote, 3 vertical asymptotes and 1 horizontal asymptote, 3 vertical asymptotes and no horizontal asymptote, or it's going to be none of the above. So when I get a question like this, first thing I always like to do with a rational function is try to factor everything if possible, because you never know if factors can cancel out, and that would give you a removable discontinuity or a hole. And notice that we can factor here. First off, notice we can factor out an x in the numerator. Notice we could also factor out an x in the denominator. And as I mentioned, let me kind of split this up here. Notice that the x's are going to cancel out in this case. And so what does that mean? That means that at an x value of 0, this function is going to have a hole. At an x value of 0, this function is going to have a hole, or a removable or a point discontinuity. Right? So at an x value of 0, it's not going to be a vertical asymptote. It's going to be a hole because that x value of 0 makes the numerator and the denominator equal to 0 in this case. And it factored out. So at an x value of 0, there's going to be a hole. So what are we left with? We're left with f of x equals 3x plus 1 over 3x squared minus 6x plus 7. So basically, this function, the way it's going to look is it's going to be this function with a hole at an x value of 0. So what we can do is figure out, okay, how many asymptotes is this function now going to have? Because the number of asymptotes that this function has is going to be the same number of asymptotes that this function is going to have. It's just going to have that hole at an x value of 0. So let's, what do you want to start with? Let's start with the horizontal asymptote. So to find out what the horizontal asymptote of a rational function is, we got to figure out what's the limit as x approaches positive infinity and negative infinity. I'm going to just do both in this case. So it's going to be a limit at infinity. And the way we figure that out is we divide everything, all the terms, by x to the power the highest degree in the denominator. So I'm going to divide this by x squared, this by x squared, this by x squared, this by x squared, this by x squared. So what would we have? We would end up having 3 over x plus 1 over x squared all over 3 minus 6 over x plus 7 over x squared. Like that. And so now notice that when we have a constant over x to the power of a positive exponent, as x approaches plus or minus infinity, notice this is going to go to 0, this is going to go to 0, this will go to 0, and this will go to 0. So we would be left with 0 plus 0, which is 0, over 3 minus 0 plus 0, which is 3. And 0 divided by 3 is 0. And so we know that this function here has a horizontal asymptote at a y value of 0. So I'll write it over here. Right? And you don't necessarily have to do all of this work here. Hopefully you could recognize, hopefully you're pretty comfortable with horizontal asymptotes. I went over this in the lecture videos, that if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is always going to be at y is equal to 0. Right? So we didn't necessarily have to do this. If this is a short answer question, you will have to show the work, but if it's a multiple choice, you could just quickly tell, hopefully, from that function by looking at it at this point, that has a horizontal asymptote at a y value of 0. If you can't tell, then I'd recommend going back to the limits at infinity lecture videos and going through those again. I have a video with the different cases. Okay, so there's a horizontal asymptote at y is equal to 0. So there's one horizontal asymptote. Well, that doesn't help us too much because all of these options have one horizontal asymptote. So we know it's definitely not going to be this one. right? This one says there's no horizontal asymptote. So it's going to be one of these four here. So what's left to do? Well, we got to figure out how many vertical asymptotes there's going to be. And so if we erase all of this, make this look nice again, how can we tell where there's going to be a vertical asymptote? Well, we can factor or try to find out what x values make that denominator equal to 0. And I should have actually mentioned that at this point, I should have tried to factor first this 3x squared minus 6x plus 7, but that actually doesn't factor smoothly. 3 times 7 is 21, and then there's no two numbers that add up to 21, or multiply to 21 and add up to -6 smoothly, no integer numbers, right? So this here actually doesn't factor, but that doesn't mean that there's no vertical asymptotes. There may be, we just have to find those x values where this denominator is equal to 0. And if we can't factor, what's left to do? Quadratic formula. So if we plug this into the quadratic formula, this is the quadratic formula over here. The b value is -6, so -6 is going to be +6, plus or minus b squared, which is going to be -6 squared, minus 4 times a, 3, times c, 7. And this is going to be all over 2 times 3. And so notice that from here, what we got to do is figure out what that value under the square root is, the discriminant. And notice that we would get 36 minus 12 times 7, which is 84. And notice that that's going to give us a negative number. And you can't square root a negative number. And so what that means is that this here actually has no solutions. And you actually didn't have to plug it into the whole quadratic formula. If you remember from grade 11, you can just look at this discriminant, b squared minus 4ac. And if it's greater than 0, it has 2 solutions. If it's equal to 0, it has 1 solution. And if it's less than 0, like we got in this case, it has no solutions. And the reason why we can just use this is because they're not asking for the actual vertical asymptotes. They're just asking you how many vertical asymptotes there's going to be. So we don't have to actually find the x values. We just have to find how many there are, right? With this, there's either going to be 2, 1, or none. But because that discriminant was negative, that value under the square root can't square root a negative, there's actually no solutions to this, which means there's no vertical asymptotes. And so this function has, as a recap, a hole at x equals 0. It has a horizontal asymptote at y equals 0, and then it has no vertical asymptotes. And so going back to this, which one of these is it? Well, notice that there's no choice here for a no vertical asymptote. So it's not this, it's not this, it's not that. And so the answer is actually none of the above. Right? So this function in particular, it actually only has one asymptote. It only has a horizontal asymptote at a y value of 0.